Hello, this is Mr. Stansbury. I'm going to take you through the notes on using technology to find binomial probabilities. At the end of this, you should be able to say, I can use a graphing calculator to solve more difficult binomial probability problems. Okay, so here's what we're going to do. We're going to take a look back at the example we had from our previous set of notes. Example 7, Beatrice the bunny has a 60% chance of making it through her entire course of the Bunny Equestrian Championships without knocking down a bar. If Beatrice runs through the course 5 times, determine her chances of, and we're going to use a calculator to determine the chances for all of these things here. Making it through 4 times without knocking down a bar, at least 3 times without knocking down the bar, making it through at most 3 times without knocking down a bar. Okay, so here's what we're going to do. We're on the TI-84, because that's what majority of people have. I'm going to show you what you're going to want to go into. Okay, it is going to be, actually I can leave this up here for now. We're going to go into second, and everything we're talking about in here is a distribution. It's the binomial distribution. So we'll do second distra. And it's going to give you all these options here. We're actually going to do some of these here later on in the course, but for now we're going to go down here, and there's 2 down here that we're going to use: binomial PDF and binomial CDF. Okay, so basically the difference between the 2 is I just look at the C and the P, and C means cumulative, so that's adding them all up, and P is just the probability of just one event. Okay, so for this first one here, we want to know down what's the probability of making through exactly 4 times without knocking down a bar. So that's going to be PDF. Okay, now before we get too far into this, it's going to give us all this information here. Before we get too far into this, I want to show you this binomial distribution for the TI-83-84. Okay, because they're going to give you this thing here. They got trials, the P, and the X, and right here it says N is the number of trials, P is the probability of success as a decimal, and the X value is the number of successes that we are looking for. Okay, so just to kind of look at in here, what we're doing right now is we're doing this top one, to calculate the binomial probability for exactly one particular number of successes. Okay, and then later on we're going to look at this here to help us figure out how to do at most, fewer than, more than, or at least. We won't use every one of these, but this will help us through these problems here. Okay, so back to this one here. 60% chance, 5 trials. We want to know what's the probability of her making it through exactly 4 times without knocking it down a bar. So 5 trials. Our probability is going to be 60%. So you can do 0.60 or just plain 0.60 works too. And then we want to know what's the probability that it will happen exactly 4 times. And we push enter and we push paste. And here it is, binomial PDF, and then again this first one is the number of trials, that's the probability of success, and then this is the outcome that we want. We want to go through exactly 4 times without knocking down the bar. Push enter, and that probability is 25.9%. So we'll just write down 0.259, which means 25.9%. Okay, before we go to the next problem, let's take a quick little comedy break.
So much the number, man, it's I feel old. Some things happen to make me feel old. For example, I read an article not too long ago. Society says the average man at 27 should be married. It's very depressing. So I don't think society factors in things like maybe me and a wife at this point in my life can come together and fit in my mom's basement, because it's not that big. It's finished, but it's damp. Sure ain't gonna want to do it.
All right. Now, making it through at least 3 times without knocking down a bar, that's when we're going to go, so at least 3 times. So that's when we're going to want to go to this binomial CDF. Okay? So this one says at least any number of successes. So this looks kind of weird here, but what we want to do is like this one here says probability that x is greater than or equal to 5 is going to be 1 minus the probability of x less than or equal to 4. So we are going to go into, we want to know at least, I think it was 3, right? So we're going to do the binomial. The only thing that's going to change is the last number, okay? So probability of 5 or more, we want to actually figure out 4 or less, and then find what we call the complement of that. And I'll show you what we're talking about. Okay. Making it through at least 3 times without knocking down a bar. So we get back into our graphing calculator, second distribution, and now we're going to go down to binomial CDF, because C, remember, stands for cumulative. It's going to be, when we're talking about just not exactly 4, but in this case, at least 3 times. So 3, 4, or 5 is what we're looking for. So we're going to push enter. Okay, so we're still going to do 5 trials. The probability of success is still 0.6. Okay. So if you remember from back here, at least, we want to come up with at least 3. Okay, so in this case here, this is at least, this is 5 or more, so that would be at least 5. So then what we want to do is we're going to do 1 minus the probability of 1 less than our 3 trials. So we're going to actually have our x value, we're just going to subtract 1, and our x value of 2. Okay, so we push enter, and then the probability of, again, what we are trying to find here, oops, that's a little confusing there, sorry. The probability of making it through at least 3 times without knocking down a bar. This here tells us the probability that Beatrice won't make it through at least 3 times. So all we have to do is just take 1 minus this, which is the complement. So we want to do 1 minus our answer, and we get 0.683. It's going to be, oops, that is 0.683, or 68.3% chance. Okay. And then part C says, what's the probability of making it through at most 3 times without knocking down a bar? So if we look at that one there, this one is at most 3 successes. So this one here is at most 5 successes. So we can actually just put in 3 on that. So we're going to go back in second distribution, and we're going to go down to, I think it's B or something like that, right? This CDS cumulative. Okay. So still 5 trials, still 0.6, and then we want to know at least 3. So we actually, since we're not doing the complement, we're just doing the actual number of 3 here. Push enter and paste, and that at least 3 is 68.3%. Okay, which is the same thing, 0.683. Okay, I realized I did a little miswrote the answer. It should be 0.663 instead of 0.683. I just misread it off the calculator. But we have that. And then just to show you from what we did in the last section here, went through for C. So this is for part C. We went through and figured out what's the probability of it saying it through, making it through at most 3 times. So we would just have to figure out not 4 or 5, and then subtract that from 100. So here was our not 4. Well, here's the probability of making it through 4 times exactly, 0.2592, which we figured out before. And then here's a probability of making it through 5 times without knocking it down. That's 0.07. Add those together and take 1 minus that, the complement, and it gives us 0.663, which is exactly the same as this here. Okay, so this is just like a nicer way to go through and calculate out that on your calculator, but you, of course, are welcome to do it with this as well from our previous section. Okay? All right, that's all we have for this section here. If you have any further questions, please feel free to ask.